what happens here with the phase shift, it told you that this was a cosine graph. Cosines, remember, always start at their A values, 0, opposite of A, 0, A, as it rotates itself through. That means that my A values would have been here and here for my opposite A's and stuff, okay? Now, that would have been my starting point if it was at
Wait, so it means
a 0. Does that make sense?
pi over 4 is
Yeah.
shifted?
Yep, that's it.
Oh.
That's a very nonchalant. Oh. So in this case here, we know that it's a cosine graph. We know that the k value, what's your k value of this one? 0. Your k value here is 0 because notice, your A is 5 and your opposite A is -5. The absolute value between the two, or the difference between the two, they wouldn't match up at 0. Does that make sense? So there's no k value here, but you do have an A value of 5, an H value. You notice that if your A value for cosine should start at 0, that value had been moved over to pi over 4. So that means your H value is pi over 4. Now it's pi over 4 is H. Is that positive or negative?
In the equation, it's negative, but it's positive here.
Correct. Yep. Very good, very good. So my cosine graph that has been shifted winds up being y equals 5 cosine quantity x minus the pi over 4. Bonjour! How are you? Get more sleep. Nerd. Goodbye. I'm joking. I don't know who that was. Do you guys? I think I might have frightened her.
Watch her be like,
Okay.
and these students.
I don't know
Go to the
that
counselor
one.
in front.
I feel bad.
She didn't like laugh either.
Well,
She's like, I don't know you. Why are you calling me nerd?
we'll all get over it. We're just trying to avoid traps. He all want to keep his arm up in the air. So like, poor brains smell it too bad.
What's 5 pi? I mean, what's
Eh?
the period? Like, isn't the period 5 pi?
I got
Your period here, in this case, your period, you want to look at, when you're dealing with cosine, we're looking at this one. Oh, we got to get our B value here. I almost forgot about that before we put this together. We got to find our B value. I almost skipped that. Notice in this case, if I move it back to your 0 part, one full oscillation occurs at what? Pi. Okay? So one full oscillation occurs at pi, which means that the period for this winds up being pi. So if my period is pi, how do you find the B value when you're dealing with cosines?
2 pi.
Your period for cosine is 2 pi, over B. So if the period here is pi, what's your B value? 2. Okay. I accidentally skipped finding the B value. So now I have 5 cosine 2 x minus pi over 4.
So the period is pi.
Your period is pi, yeah. And this one wasn't brought all the way back up to end where the cosine would have gone through. What they're doing here is they're showing that you can kind of backtrack it, seeing that you go through one full oscillation at pi. And that's okay, because that's going to do the same thing. It's just shifted over. Okay? Now, the sine one that's below that, I think we started number 4? I don't remember which one we did, but I think we started one of them. Was it 3?
Let's do
Because I remember you mentioning
We do
that
both.
line.
Let's do both.
Yeah. Because then our sine value here, I think we just did the k value of this, and I think I might have done that as a cosine graph because I didn't read the instruction. I think that's what we did, right? Did we write that as a cosine? But didn't we do it?
For which?
Let's just do
Actually, you know what? I think what we did was we talked about this dotted line being the 0. I think that's what we talked about. Because in class, I think we did something else that was different. It was so long ago, I don't remember anything.
That's not one of my graders.
Well, this one's going to be a shifted sine graph.
I said that it was a cosine, and then I just said that like it was shifted vertically, 3 because like.
Now, they want you to think of this one being a sine graph, and what I want you to remember is that sine values start where? They start at their zeros, okay? Sine starts at 0, so a sine graph would be 0, A, 0, opposite A, and 0. So if my sine graph is starting at a 0 value, excuse me, what I want you, well, in this case, what's your k value? That's pretty, we'll start with that. What's our k value? Whereas 0 would have been here, it's been moved to here.
3.
So it's 3. So k is 3. All right. We can also figure out your a value. Your a value is the distance between your 0 and your peaks and valleys. So it's 2. Now, if you start thinking about this, this sine graph has been moved. Has it been moved left or right? Does it matter how you say it? No, it doesn't. You can say it's been moved left, or you can say that it's moved right. You're shifting still by it being a periodic function. The shift, if you do it correctly, it's the same. Okay, does that make sense? So if I started at the 0 and I move it to the left, whatever, pi over 4, it would be the same if I started at the 0 and moved it to the right, pi over 4. You're still going to get the same oscillation, same period, and all that other stuff. So, I would probably say that I'm looking at knowing that my sine values always like to start at a 0 value. I would like to think that it starts here, and it goes through the cycle. So I would say that this has been moved to the right. Okay, that's how I would think. Because I'm a positive person. Yes, ma'am.
Yeah, how would you know? Because couldn't technically the point before that be 0 too?
Correct. That's the idea. A lot of times when you don't have the parent function, if they didn't draw in the parent function in dotted form behind, prior to the shift, you're not exactly sure have you been moved left or right. Now, what I like to do a lot of times is if I give you a problem like this, is that I would probably put in the parent function, doing something like that, so then you can figure out where has it moved to. Okay? Does that make sense?
Yeah.
So.
I don't know. I think I just let you do that and we choose them.
So in my mind, I'm thinking that it got moved to the right off of 0. Okay? Now, the other thing I want you to think of is sine, generally it goes to its a value. So if I move it to the right, did the graph go up or down? From this, by calling this my starting point, did my graph move upward or downward? It moved downward, didn't it? See how the graph goes down? So is your a going to be positive or negative in this case? It's going to be negative. Good. So it's going to be a negative 2. All right? Just by looking at that shift. Now, could you have been really, really crazy and moved it all the way to here? Oops. Moved the point all the way to here and still had a positive one?
Probably.
Yeah. So it's all, perspective here. That's what's crazy about writing equations of graphs given value, because there's kind of multiple answers here. So I'm going to say that my a value is negative. And if I look at it, knowing that my shift moved over 3 pi over 2, if I look at one full oscillation, peak to peak, that would be a period, wouldn't it? That value is at, what? 6 pi. So I know that my period, my period is 6 pi, but that has to equal 2 pi over b. You all right with that? which gives me a b value of what? 1/3, very good. So I have a b value of 1/3. And my h value, I move to the right 3 pi over 2. And now I have everything to put it together. Yes, sir?
On the quiz tomorrow,
Yeah.
are you going to have any equations like this where there's like 3 possible different equations?
You know what? With any shifted graph, there are always going to be multiple answers. Okay, there's always going to be multiple answers to that. What I was trying to explain to Emma was that what I like to do when I give you shifted graphs to write out, I will say write the equation of this cosine graph, and I will give you a parent function in dotted form, and then the solid form of the graph. That way you can see where did it start with like its a value, and then where did it move to with its h's and k's. Does that make sense?
Yeah.
So-
it just makes it so you don't guess.
Yeah, it takes a little bit of the ambiguity out of it.
Okay.
I mean, you could do this one, and you're right, you could have 5, 6 different answers to it. From my perspective, that's cool, but it's a pain in the ass to read. Because then I gotta go back and check, so does that work, and go through all that, and that's,
You can be a pain about it too, because we're like, well,
Right.
I got this answer, but there's
Yeah.
like 3 other things I can do.
Yeah.
Which one's the right?
yeah. And for all intents and purposes, if we understand, the idea is, can I get you from looking at a graph, what the phase shift and what happened to it from being the parent to the shift? And if you can do that, that's great. All right, that's a good question. Not so bad.
Sorry, I'm gonna catch it, the periods, because we have
Kathleen, I love to harass you because it's fun.
I know.
Which ones? You probably want this, don't you? Did I post it? Oh, I did. I did 3. Which ones? The answer is yes. Yeah, oh, sorry about that. Let's see. So identify F2 period, phase shift, and all that fun mumbo jumbo.
But you just have to.
So if I look at this one, since my b value is hiding in the parentheses, I have to bring that out. So this is going to be a -10 cosine of 1/6 x. That's not bad. So the period here is 2 pi over 1/6, otherwise known as 12 pi. Okay. And then the next one, same basic idea. I take the 2/3 out, so I'm going to have 5 minus 2 sine 2/3 x. Gives me a b value of 2/3. So it is 2 pi over 2/3. So I multiply by its reciprocal coming up, and I'm going to get 2 pi times 3 over 2, which gives me 3 pi. All right. Were you forgetting to do the reciprocal? It's very common. Very common. Because you see, oh, it's 2 pi over b. Oh, it's 6. It's 1/3. Yes, sir?
Can you do the phase shift for 7?
Yeah. Phase shift, remember, that's just the fancy way of writing h. That's all that means. Phase shift is just a fancy way of writing what's your h value. So in 7, when you take the 6 out, we have 3 cosine of 6x plus, what is that, pi over 6 then? Hi, how are ya?
Wonderful. How are you?
I'm great, good to see you. Hey, you want to do some phase shift, sine and cosine and tangent stuff?
Sure.
Come on, it's fun.
Haven't done this in 3 years.
So, remember how mean I was by hiding b values inside the parentheses?
Instead of pulling them outside.
Yeah, because then I do that.
Because now it's x plus pi over 6.
You're right.
Yeah.
So, what's your shift?
Does that mean it's shifted to the left pi over 6 units?
You may stay in my classroom for as long as you like.
Wonderful. Because it's negative k value, correct?
Correct.
Perfect.
But it's an h, but that's okay.
It's close enough.
Remember?
It's been 3 years.
Horizontal,
K is
vertical. See?
Yep.
Taught them everything I know, guys. See you, Clay. There is method to the madness of my brain. People do retain things that I teach them. It's weird. Somehow. But it's Clay, so Clay just remembers everything anyway, so here you go.
So when you wrote down the phase shift as an answer, it'd be the opposite of what it is.
Yes, sir.
Okay.
Because remember, it's always, it's x minus h. So how did I get a positive and then it had to be a... Alright. So you moved over, moved left, pi over 6. That's an awful fraction to work with. What else we got? You guys have a good weekend?
Yeah.
Good. It's great out. It's beautiful. We were trying to put together. My kids got a trampoline. Yeah, I can see that. My kids got a trampoline from Grandma and Grandpa for Christmas. So finally had great weather to put a trampoline together. And guess what? They didn't ship all the parts in the boxes. So right now, my 2 children, beautiful, beautiful weekend. Best weekend we've had in a long time. Want to jump on a trampoline, but what's on the trampoline? The giant poles that are only about this high off the trampoline, which could just impale them because they didn't ship the other parts to put the rest of it together.
Does it have a net around it?
It will, yes. Eventually, yeah. The netting will go up on that. I made the mistake as a child to be on a trampoline without a net because they didn't have those back then because they didn't really like children. I don't know how I survived now, to be honest with you. And I fell off of it and my ankle went like this. It's great.
It's
You know what's awesome?
Not supposed to do that.
You know what's awesome? Once you get it all done, you gotta put a sprinkler under it and then have it on.
Oh, I
That's
did
Yeah.
that. It's so
See, what
funny.
you gotta do, you gotta push your trampoline next to the pool, and then you jump on the trampoline and jump into the
Don't need to
pool.
don't get my children any ideas. They can probably try and do that. So, what else we got, guys? This is our time. Maddie, what's up?
That's aggressive. It's only 8:56 in the morning.
How is that aggressive?
That was like loud and very exciting.
Was it AGGRESSIVE aggressive? I'm an idiot. What do you want?
Can you do like one of the 9 or 10 or 11 or 12, like one of those?
In here?
Yeah. Because like
Give the following, write something out?
it's just like the B value. Because do you have to hide the B value like you do?
No, you don't. You don't.
What do we do?
So if I have a sine function, so we go through. It's just basically filling in the blanks on this one. You don't have to hide the b value. If you want to, you can, but that's just more work. No reason. So you have 1/2 sine. The period is pi over 3, so we have to figure out how does that equal 2 pi over b, which, what do you get then? 6? So b is 6. So I have 6. There's no horizontal shift, so it's 6x, and then it's minus a 4. Does that help?
Yeah.
Yeah, you don't have to hide. You can be part of our family and not have to hide from relatives. Sir,
I didn't do this, but if someone did,
what do you got?
for
Bud?
example, number 10,
Yeah,
multiply the 1/2 by over b into the rest of the,
it's not wrong.
Okay.
It's just extra work.
you wouldn't count it as wrong.
No, it's just extra work.
Okay,
You don't
I'm
have,
just
but if you
curious.
do that, you gotta make sure you do it right.
Yeah.
So that's why I'm not worried about that. I will. I'm not requiring that you hide your b value. You don't need to.
But
You
if
know,
you do, it wouldn't be wrong. You would count it as other.
as long as it's right.
Okay. I just wanted to. Okay.
Because I do know that in. We should have a pre-calc. I do know that in pre-calc, they yeah, they hide it all the time. That's why I kind of just give you guys the idea of where it's gonna happen. So that way when you see it, you're gonna be like, oh, that crazy guy last year wasn't really smoking crack. He knew what he was talking about. But it's such a hard habit to kick because it's so delicious. What else we got? Oh, isn't this week the week that you guys are watching Mice and Men?
I love it. What?
Yeah.
I love the ending of
Are
it.
you-
Yeah.
Are they watching it now? Are you finishing it today?
And what?
Yes! Oh, no! Because we got a quiz tomorrow.
Why? What's going on?
Push back till Friday.
I have to show you guys a video.
Oh.
Wait, why are
Show
we?
it to my phone.
Yeah, I did.
I don't remember it.
I will show you guys the video on Wednesday. So you'll have to remember the ending for an extra day, because I know once you see it today, you'll be like, "Ugh."
I still remember the ending. I love the ending.
So
It was.
the cow ran away with the spoon is the ending. Just to spoil it for you. What else do we want to look at? Sure. So let's see. We have amplitude, so we have sine function y equals a sine b x minus h and a k. I have no k value to worry about, so that one's, I just go whatever. And then period is 4 pi, so 2 pi over b is 4 pi, which means our b value is.
Yeah, that's one.
All right, so here's what I want you to remember to do. This is fraction equals fraction. Whenever you get fraction equal fraction like this, exchange-o, change-o. Okay? Just do an exchange, write it out as a one step and do an exchange-o, change-o, simplify. It works all the time. Okay. So that gives you a b value of 1/2. An a value of 7, and an h value of negative pi over 3. So you just write it out as 1/2 sine, oh, wait, sorry, my b value, I got my half and the 7 mixed up because they're so similar. Quiet you. There you go. If you got fancy, you could go 1/2 x plus pi over 6. That's just kind of silly. What's that? Extra work, yeah. But what happens if you wrote pi over 5? Your extra work has gone wrong. It's all bad. Don't die. What else? I don't know, for some reason I'm in a good mood today. It's beautiful out.
Yeah.
I gotta go buy a lawnmower. Just so I can share that. What else we got? Squirrel.
Why is there,
Yes, sir.
why is there still a Santa hat on fish?
Why not? Because there's always been a Santa hat on the fish.
Mr. Murphy, are you gonna give us like a review packet?
This was it. Yeah, that was a Christmas fish. It's the Christmas fish from Richie Sakarukarukiaka.
Richie Saru?
Yeah,
He's so
I'm gonna
funny.
jump off for a question. Do you have any problems that you would suggest for studying?
you know, the problems that I had on here for the graphing stuff, that's about as complex as I like to get with these things.
It's too complex.
I don't think I have anything. I think I've gone through and printed everything. Oh, I have more of them.
It takes forever.
They do take a while, yeah.
In number 10, I think I might have done wrong.
I've got a couple more sine, cosine, tangent ones. If you guys, I have some more problems here. If you guys want,
Do you have an answer? you
Wait,
can
I
give
love
us?
yeah, some of them are ugly.
I didn't even do these problems.
Well, if you guys want to look at some more extra stuff to look at, extra graphs and whatnot. Yeah. Yes, ma'am.
Do you have an answer for this? I want to know if I did this one right.
Oh, that's right. 'Cause I told you it was a tangent one. I don't know.
To subtract 4 pi over 3 when it.
I think I need. I'm gonna just do that one real quick because I don't have that as an answer key because of the because remember I switched it to a tangent at the end.
Yeah.
So what was that one again?
It's y equals 4 tangent of what's the thingy over 2, alpha over 2,
X. Theta.
theta, plus 2 pi over 3. And then minus 2.
Alright. So in this one here, what you want to do is take out the half first. So you get 4 tangent
2
1
x.
half. Then we have an x.
The study guide or the other one?
Screwed that up right away.
Yeah,
All right.
for whatever reason.
Well, if you think about it though, yeah, that's gonna mess up everything, won't it?
Well, because wouldn't you multiply by 2 to get
No.
the x?
Because here you gotta take
I was
you gotta
paying
take
attention.
the half out. So now you think of it this way: 1/2 times something equals 2 pi over 3.
So if it was 2x, then you would take out the 2.
So now half of what? Think of it this way. This is actually pretty easy now. Half of what is 2/3? Well, half of 4/3 is 2/3. So this becomes 4 pi over 3 minus 2.
Oh, that's what I did.
So all you screwed up was the a, but you still got 4 pi over 3 for your shift.
Yeah, for whatever reason, I ended up with 4 tangent
Oh, thank you, B.
x plus 4 pi over 3.
Well,
Well, because I
you
multiplied.
made a dumb mistake, but it worked.
I
Now here's
multiplied 2 pi over 3 by 2, and that's I got 4 pi over 3.
well, that's just dumb luck. So here's the thing: if your shift points are all correct, which they probably are if you did that right, the only thing you screwed up then is your a value.
Well,
E value.
I multiplied. Sorry. I multiplied both of those terms by 2. So then I took out the 2.
Oh,
and then,
okay. You
yeah.
can't do that because you can't distribute here because then you'd be distributing across everything. All right, look.
That's what it's doing, but that's not really.
So A is 4, B is a half, which gives me a period of what, pi over half. So it's 2 pi. H value of negative 4 pi over 3, and a k value of negative 2. So tangent graphs, first thing we worry about plotting tangent graph parent function.
see, my graph got super messy because what happened was like I drew it out and then my period was like pi over 2. So
Okay.
then I had those being pi over 4, and then it was like I was subtracting 4 pi over 3, and I was like, why am I subtracting all the way over back?
Oh, all right. So we have a negative pi. We'll figure this out. A positive pi. We have breakpoints. Negative pi over 2, pi over 2. So tangent graphs, remember, the tangents all for your parent function is always going to go through 0. The halfway points between your 0 and your asymptotes are where your elbows go. So you're either dancing up or you're dancing down, depending upon your A. Our A value is where the elbows wind up at, so they're wind up at 4. And it's positive, so it's dancing upward. So my parent function is doing this. Now, the easiest thing to do, especially with tangent graphs, is to always go with ordered pairs. Actually, for most of these, especially when they're crappy shifts. This is a kind of a nasty shift to add the fractions with.
That was I was getting like negative 35 pi over 24, and then negative 29 pi over 24. It took so long.
This is y minus 2. Can you shift vertical asymptotes up and down? No, but we can move them left and right. So if I have to move it a negative pi, and I move it negative 4 pi over 3, That's the exact same thing as saying negative 3 pi over 3. So negative 3 minus 4 is what? Negative 7. So this will be at negative 7 pi over 3. If I move 3 over 3 and I subtract 4 over 3, I'm at negative.
Wait, so you just kind of disregard the 1 minus 2 part?
Yeah, because because it's vertical. If I move it up, aren't asymptotes moving up and down already?
Yeah, but you can't move the points.
We are. I'm moving the asymptotes to negative 7 pi over 3.
No, but I mean, like, you can't move, like, the points up and down?
I haven't gotten to those parts yet.
Okay.
My first 2 points I put on here are always my asymptotes. Because when you plot tangent, you always want to plot your asymptotes first, because then you find your midpoint, and then you get your secondary midpoints. So negative 7 pi over 3, and I'll put the other one at negative pi over 3. Now, knowing already that I have to slide this up, I know that my original 0 value was at 0, 0, because tangent's nice, it does that. I just have to make that a new 0 value at negative 4 pi over 3. And your k value, I think it moved downward, too.
Yeah.
So then it'll be at negative 2. So I know that's where
Okay, so
that's
you
going to
still-
occur.
Because the asymptotes are still there, but you still, like, move the point.
Correct.
down.
Yep. And what's nice about tangents is that you know where the midpoint value is going to wind up here. Because what's negative 7 plus negative 1? What's half of negative 8? Negative 4. That's why I get that. And then my value here goes to 2. And then if I move my other ones, excuse me, and yeah, this is where the halvesies get kind of messy. If I do negative 1/2 and I'm moving it negative 4 over 3, think of this as the same, oh, I'm sorry, starting at, think of this as negative over 3. What's half of 3? So that'd be what?
You have to do 3 pi over 6. Or, 4 pi
Yeah,
over
I have to
6.
go, if I go, yeah,
Negative 4 pi over 6 minus.
yeah. And that's what kind of stinks, because then the other one you have to do 8 pi, then you have to make that 8 pi over 6 as well to get the common denominator. So by moving that one over, what do we get? Negative 12 pi over 6, which is 2 pi, negative 2 pi. That was awful. And then comma, this one was at negative 4, so it becomes at negative 6.
Can you just leave that K part in like whole numbers?
I try to. I mean, and honestly, this is probably the worst case scenario by having to get that extra common denominator, that more work, instead of being like a 2 and a 4. I think 2s and 4s are pretty easy, but if it's a 3 and a 2, you have to go to a
I'm
6.
subtracting like negative 1/8 minus like 4/3.
There's this one's kind of bad about that. I'm sorry, I didn't realize that the H values would be that nasty. Does that make sense what I'm saying here, guys? I'm not trying to trick you with the H values by your shifts here. I'll try and make sure to keep it where it's like a 2 and a 4 or a 3 and a 6, something that's got a quick common denominator, as opposed to 2 and 2/3 and a half. Negative, yeah. Don't put it past me, but I'll try not to. Then the other one, what did we get here? We get 1/2, 4/3. So that's 3, 6, and 8, 6. So that's a negative 5, 6 pi. Oh, that's about here. It's more than 1. And then this becomes over at 2. Okay. Sometimes people find it helpful with tangent when they put in their parent function to put the vertical line through what your 0 would have been at. Sometimes people find that to be helpful. Okay. That might be your worst case scenario problem, to be honest with you, that awful shit. Yes, sir.
graphs and all graphs in general, would you mark it wrong if I made 2 graphs, one for the parent and one for the actual?
No, I wouldn't mark
Just to
that.
make it look nicer?
No, that's perfectly fine. A lot of people do that. I always like to leave the parent in there and then move it off of it. That way sometimes when I see students, when they do that, you're right, it looks a lot cleaner. But a lot of times when I see them do that, sometimes they forget what they just did and they mess up on the secondary one. Like, as an example, like with the A value. Let's say your A was negative and you did the whole opposite graph, but then you went to the next one and you forgot to put it negative and you go the other way around. Whereas if you're on that, you saw right away, oh, it had to move downward, and then you make sure you put it downward. Or a lot of times what they'll do is, I'm a huge proponent of making sure you put ordered pairs. Don't be surprised to say list your ordered pairs, because by listing them out, it also helps to force you to be able to do your adding and subtracting. And that way you know where your stuff goes. But I'm not gonna, if you want, I have no qualm, I have no quarrel with you, good sir. Isn't that like a Romeo and Juliet thing?
Something like that. So if we do it,
You said doo-doo.
If we do it, we should be extra careful. Is what you're saying?
Yeah.
Okay.
You didn't find that humorous, I did. He said doo-doo. I really like 12.
Yeah.
That's a little. Like
8,
There we go.
9.
somewhere in there.
6.
I'm not double digits yet, I'm working on it. I'm getting there, slowly but surely.
Still
I mean, I don't know if you ever really hate the double digits. Maybe when your kids are like older.
No, there's a lot of fun stuff.
Why do you keep throwing me something?
What else we got? Anything good? You'll be okay. It'll take you a couple days to. You're just sitting there going, oh God, look at all this.
I put it away. I was like, I
Your brain really hurt after a while, I
Got
can
it.
imagine.
Figured it out.
There's a lot in this.
I watched like the videos of the lessons like
Yeah.
7 times. I was like,
No, you don't.
But in the grand scheme of things, if you understand how that in a sign graph, that's the whole thing. This is half, that's a half, and that's a half. So if you know that your period, even your period is pi over 2. It starts at 0, it ends at pi over 2. Half of a half is a fourth. Half of a fourth is an eighth. 1/8, 2/8, 3/8, and so on. That's basically how I do all of it. It's the easiest way to do it. Same thing with cosines. With tangents, when you do a tangent one, you always put those in first, because that distance is always your period. So if this distance here is pi over 2, half of it is on one side, the other half is here. So this would be a pi over 4. This would be a negative pi over 4. What always happens between them? 0. And what's halfway between here? An 8. You just break it into that. It's much easier than trying to do what I think the book does a lot. They'll do the 1/2 your period, 1/4 your period, 3/4 your period, instead of just thinking about it. No, it's just breakpoints. It's all there. If you get to that part, once you get those, the oscillations are easy. That's the easy stuff. It's being able to place it. And don't worry about space, because they all look the same. They just have different numbers. They all look the same. I would imagine you would. I thought that would help a little.
That was like the one.
Every little bit helps.
flex right now. I'm pretty sure I have like
Yeah. No, I know.
Yes,
I hated it. I literally was like,
I know,
And they're
it's,
like, they were worried I had mono because I was like, this is awesome. Like,